So as we know, till last class, we studied two types of potential energy. So that is what gravitational potential energy, and another one is what, guys? Everybody?
Elastic potential energy.
One is gravitational potential energy. So what is the formula for gravitational potential energy? Everybody? Gravitational potential energy is equals to what?
MG.
mgh. Okay. mgh. Now I will say the one more thing. Please make it. For example, if a body has been moved to from this height h1, of course already we have done. Now from that point it has been moved to another point. That is what? Let me take. First it is in first floor. After certain time it has been moved to the second floor. So now what is the potential energy? Change in potential energy. So of course, this I can say you h2 height. Okay. So now if you notice it from the ground, so at this point, the potential energy is equals to, let me take it as a potential energy is equals to mg into h1. Am I right or wrong, everybody? Yes, please. And at this point, potential energy P2, which is equals to, I'll take mg into, from the ground, what is the height? Everybody, h2. Understanding how? So now, in these cases, if a body is moving from one height to the another height, then change in potential energy, like change in momentum. So what will happen, anybody? Change in potential energy, which is equals to final potential energy minus initial potential energy. Please learn it. So change in potential energy, I'll write as a delta EP. You can take it as a delta EP, or you can take it as a delta U. What you can take, guys? Everybody? Delta U or delta EP. So delta U I take. Final potential energy is UF. Check it, everybody. And initial potential energy is UI. U is the symbol for potential energy. Understand, everybody? So UF minus UI. So UF means what? mgh2 minus UI means what? mg. Everybody. mgh1. So which is equals to, mg is common. So what is the formula will come? h2 minus h1. Okay. So that is only called as change in what? Change in, respond. Change in potential energy. What potential energy? Gravitational
potential energy.
Hope everybody understand. Mr. Kishore, Lingesh, Hasani, Sudhakar. So change in gravitational potential energy, this is the formula. Mass into acceleration due to gravity into final height minus initial height. Understand? Agalya, Shivani, that is. Now, same way coming to the elastic potential energy. Elastic potential energy also we can represent with the U. So what is the elastic potential energy formula? Yesterday only I have done. Speak loudly, everybody. Half into k into x square. Am I right or wrong? What do you mean by x, guys? X means what? Extension. Yeah, extension in the spring. Am I right or wrong? Or elastic body. So that is what we used to call as X. Am I right or wrong, guys? Please respond. And what is mean by K? K means what? We all studied. Yesterday only studied.
Spring. Constant spring.
Yeah, spring constant. Constant spring kadayad mari. Spring constant. Understanding? So that is what we have studied. Yesterday we have done or not formula. Elastic potential energy formula is half into k into x square. Am I right, everybody? Please respond. Now, so if the spring is present, as it is having a initially discharge, now because of weight, it has been elongated till here. I have stretched till here. So this is what, let me consider x1 distance. What is this one? We'll consider as a, all of you? Yeah.
Sir, Hooke's law.
Yeah, Hooke's law, Mari. X1 distance. And after certain time, the distance, the elongation of spring is extended to up to x2 distance. M, and M. So all of you check it. So from here to here, it is been extended to x2 distance. Do you all understanding? Please respond, everybody. X1 and x2. Then what is the change in potential energy? Change in what potential it is? Change in what potential? Elastic energy, which is equals to final elastic potential energy minus initial elastic potential energy, which is equals to what? What is the final potential energy? Half into k into, what is that, everybody? x2 square minus half into k into, what is that? Respond, x1 square. So that is what we used to call as, respond everybody, delta U, change in elastic potential energy. I hope everybody clear. So in this, if you want, you can take off 1 by 2 k is common. So what is remaining? x2 square minus x1 square. So x means what, guys? Extension in the spring. Okay, everybody, please respond. All of you. This is only change in elastic potential energy. Hope everybody understood. Understand, Kavya, Mari, Shivani?
Yes, sir.
Yeah, Mr. Gokul. So this is what you all people need to remember it. So change in potential energy means it is either it may be gravitational potential energy or maybe elastic potential energy. First learn general formula and then change. Change in potential energy means commonly always remember this is the formula. Change in potential energy delta U is equals to final potential energy minus, everybody, final
Initial
potential energy minus initial potential.
potential.
So that is what you have to remember. All of you clear? Yes, please.
Yes, sir.
Yeah. So please make it. This is very important. Mr. Darshan, understand? Alfin, I'm calling you. You have to respond me. So that is what. So potential energy is due to the what, guys? Two things we studied. Potential energy is due to the what? The potential energy possessed by the body is due to the two things. What is that?
Due to change in state and motion.
Due to the position. Due to the position
Or
or
motion or
due to the
state.
state. Okay. So due to the position or state, the energy possessed by the body, which we used to called as potential energy. These potential energy is two types: gravitational potential energy, and second one is what? Yes, please. Elastic
Elastic potential energy.
Elastic potential energy only we can say spring potential energy. Spring, elastic. Elastic means that any elastic body. So we can say spring potential energy. So spring potential energy is also same formula. What is the formula? 1 by 2 k x square.
X square.
Okay. All of you. Elastic potential energy depends upon the nature of the substance. That is what? How much it can extend.
Virtue of state.
Yeah, virtue of the state. That is what it is. So the state is changing from here. The position is changing from here to here. So that is what it is. So this is what about potential energy and the derivations and the change. The most important concept. Again, you will experience it. Many, when you are solving the numericals exercises and all, many things you will find it. And as well as for foundation and as well as NEET and JEE also, this is one of the most important concepts. 11th class, chapter number 5, the chapter name is called as Work, Energy and Power. The same chapter what you have, and power. So there you will get again everything similar to the things what you are going to study now. So by that time you will solve different sums and all. So numericals and all very entirely differently you are going to face by that time. So this is what about potential energy and its types. I hope everybody understand. Anybody having doubt, please kindly let me know. So if not, if you understand, please don't join late. This much join means you'll miss. Abhirami also late today. Arasini also late. I don't know why, but that's fine. So please avoid it and make it be on time. So now let us comes to here, kinetic energy. So the next type of mechanical energy, we are going to study what, everybody? Kinetic energy. Okay. So now all of you remember, if it is defined as the energy possessed by a body by virtue of its motion, understanding? So every moving body will possess what energy? Yes, please. All of you.
Kinetic.
By every moving body, it will possess kinetic energy. So either it is moving horizontally or vertically, doesn't matter. Every moving body, the energy possessed by, understanding? Energy possessed by virtue of its motion. That is energy we used to call as what? Everybody? Yes, please.
Kinetic energy.
Kinetic energy. Understanding? To set a body which is at rest into motion, so we need to apply the force. Am I right or wrong? All of you? So for example, there is a car. Now car is in state of rest. Car is in what? State of? Everybody? State of rest. Now if you want to make this body into motion, so you need to apply the force or not? Everybody? I want to make this body into motion. So that definitely I need to apply the force or not?
Sir, so one doubt, sir.
Yes, ma'am.
So we can also write the energy required to move an object.
Yes, yes. That is what work done. That's what we'll say. That's what I'm going to speak now. Do you understand, everybody? So I consider car is in state of what, everyone? Car is in state of what? Rest.
Rest.
Now what I have to do it? What is my desire? I want to make them into what? I want to make it into state of motion. So if I want to make it a state of motion, I need to do something. I need to apply what? Everybody. I need to apply the force. So the force on it, and then it will set into what? If I apply the force, then automatically it will set into what? Yes, please.
Motion.
It will set into motion. Now, so the force which we apply, it is displacing the body. Am I right or wrong? The force which I apply, it is showing the displacement of the body. So that force and displacement means you can calculate something. Anybody can? Please make it fast. Force and displacement in what you can calculate? The force which we apply displaces the body and means work is done or work is not done. Everybody.
Work is done.
Force. Please respond. The force we apply displaces the body. The force we apply displaces the body. So means in a sense of work is done or work is not done. Everybody.
Work is
Done. Understanding? So the work done by, the work done on the body, which is equals to energy possessed on the body. Am I right or wrong, guys? Everybody? Yes or no? All of you. Please respond.
Yes,
so whatever the amount of work I have done, which is equals to the stored in the form of energy, which is equals to energy possessed by the body. So that energy only we used to call as what? Yes, please.
Kinetic energy.
Only we used to call as what? Kinetic energy. So whatever the force I am applying to make the body from state of rest to state of motion. So due to my force, body will show some displacement. It may travel x meters or x plus y meters, doesn't matter. So whatever the distance it is traveled, understanding, which is equals to the total work done on the body. Am I right or wrong, guys? Please respond. All of you. So the total work done on the body is basically stored in the form of what energy? Yes, please. It is the work done is stored in it in the form of which energy, guys?
Kinetic energy.
Kinetic
Energy. Because body started what? Because of body started
Motion.
So the energy possessed by virtue of its motion. What energy we used to call, everyone? Yes, please.
Kinetic energy.
Kinetic energy. That is what you should understand. Okay. Now, let us take another thing. Suppose I want to set a body like a body which is set in motion can put another body which is at rest into motion. Means, for example, see, Mr. Kishore car is in stationary. He is having a very cutie car, small car, and Mr. Mari is having now a big lorry like something. Now all of you observe, Mr. Mari is coming with 50 km/h. Now he is posting what energy? Everybody? Yes, please. He is posting
Kinetic energy.
kinetic energy. Now, Mr. Kishore is having what energy? Zero energy. Am I right or wrong? He's on the ground. He's on the ground means what will
Yes,
happen, guys? He's at rest. Rest
Yes,
means
sir.
what is the energy possessed by him?
Zero.
Rest. Zero. Now, Mr. Mari will come and hit this Kishore car from the back side, so that Mr. Kishore car also will start moving. Am I right or wrong, everybody? Yes, please.
Yes, sir.
All
Yes,
of you?
sir.
So means
Yes, sir.
the body which is already in motion, the body which is already set in motion, makes another body into motion which is already in rest. Am I right or wrong, everybody? Yes, please. Respond.
Yes, sir.
So, a moving body, from this I can say, moving body is capable of doing work. Am I right or wrong? Moving body is capable of doing work by virtue of its motion. Means how the Kishore body is coming into the motion. Because of the Mari Lari is in motion, due to that, it makes another body is also into the motion. So every moving body is possessing the energy. Every moving body is capable of doing work. Will you all agree with me, everybody? Every
Yes,
moving
sir.
body is
Yes,
capable
sir.
of doing work. Is it right or wrong? Everybody, please respond.
Yes, sir.
Yeah. How many of you know billboard? Billboard terema. Billboard. Actually, we'll say billiard ball. Billiard ball terema. How many of you knows billiard ball? Movies and all, big people will play
Yes,
that.
sir.
Billiard balls.
Yes,
you know
sir.
people? Yeah. What is the use of billiard ball? And what is the game? Anybody knows? Billiard ball. I think online also people used to play this. So billiard. Anybody can?
What is this, sir?
Yes. Billiard ball. What will exactly happen? Anybody can tell? Girls.
Sir, what is that ball, sir?
Billiard ball is தெரியாதா மாடி? Okay, I'll show you. So if you don't know, that's fine. But if you see, definitely you'll remember. Movies and all used to notice it. Big people. Yes, yes. So they will play like we can say this. Like 1 minute.
Possess
They will
the
hit
force
with
to
the
the balls.
Yes, yes. They will hit one thing and it will go and will hit the other balls. Okay. Billiard.
Pool ball.
Yeah. Billiard. Billiard ball. This game, you all people knows mine.
Pool, sir.
Yeah, I don't know what is the name. Basically, the original name is billiard ball. So I think you all knows this game. Am I right?
Yes, sir.
Now, if you notice it here, actually, this white ball only the man, the person who is playing, he will hit this ball. So he will actually this all the balls in state of rest. So what? Yeah, pool ball. Kishore, okay, I don't know. So anyhow, thank you. Yes, yes. So now, by applying the force, they will make this white ball into the motion. They will set into the motion from state of rest. Am I right or wrong, everybody? Yes. All
Yes,
of you
sir.
set into the motion from the state of rest. Now this ball will go and will hit other balls. Understanding? And these all the balls are remaining balls are in what? State of rest or state of motion?
State of rest.
Yes.
Motion.
And state of rest. Only this white ball is in state of motion. And this white ball will go and will hit. And makes other balls also set into the motion. Am I right or wrong? Everybody? Yes, please respond. Set into the motion. Means, can I say the moving object is capable of doing work? Am I right or wrong? By virtue of its motion, it is making the objects to move. Means one moving body is trying to make another body set into the motion, which is in state of rest. Will you all agree with me? All of you?
Yes, sir.
Yes, please.
Yes, sir.
So, that is what. So if you notice it here, the billiard ball hits a stationary ball and make it move. The ball which is just a moving billiard ball will go and will collide with another ball, makes that ball is also set into motion from where? From rest. So I can say the moving body is capable of what? Every moving body is capable of what, guys? No response. Capable of what? Capable of doing work.
What?
Capable of doing work by what? Why they are doing work? By virtue of its, due to the what?
Motion.
By
It's
Motion.
motion.
that is what we used to called as kinetic energy. Do you all understand, everybody? Clear?
Yes.
Yeah. So please make it. Anything doubt, please let me know. All of you clear? Yes, please.
Yes, sir.
Yeah, make it. Understand whatever you understand, you write it. See, understanding is very important. Agale Purima, Agale Shivani, Kavya.
Yes, sir.
Yeah,
Yes, sir.
please make it.
Yes, sir.
Hasini, Sudhakar, Kishore, Lakshya.
Yes,
Yes,
sir.
sir.
Arasini, understand Arasini, what is kinetic energy? Yeah, please make it. So now example. So if you take the examples, all of you observe. Can you give any one example for kinetic energy? Suppose a bullet is moving with a high velocity. So what energy it will possess? Anybody? A bullet is,
Kinetic energy.
yeah, a bullet moving with,
Sir, one doubt, sir.
yeah.
Kinetic energy is the energy which is applied on the body to move.
No, see, listen, Mari. Whatever the work done by you to set the body into motion from state of rest, to set the body into motion from state of rest.
So we
That
can
is what?
also use the formula Fs.
Yes, yes. The work done, the total work done by the body to set into the motion, which is equals to energy possessed by the body. Do you understand?
Yes, sir.
Yeah. High velocity possesses what energy, guys? Everybody?
Kinetic energy.
Possesses kinetic energy. So now, this moving bullet, you tell me, it will start penetrating deeper into anything. Am I right or wrong? For example, it will start hitting the wall, or if a person is standing here. So now you tell me, it will come and will hit, the bullet is coming and hitting. It will go deeper inside the head or not? It will hit the person head, means it will go deeper inside. Even you can see movies and all, the bullet will come backside also. Am I right or wrong? Everybody? Yes, please. All of you.
Yes.
So,
Yes, sir.
how it is going inside? Because of what? Because of what energy? Because of it is capable of doing work. It is capable of drilling. It is capable of penetrating into the wall. It is capable of penetrating into the person's body. Why? Because of what? Because of what energy? Kinetic energy. That
Kinetic
is
energy.
what you have to remember. So a bullet moving with a high velocity will possess kinetic energy. So due to this kinetic energy only, what will happen? The bullet can penetrate into, the bullet can penetrate the object it strikes. Penetrates the object, it strikes. So that is what you can say, what is kinetic energy. So what is kinetic energy? Simply, if you want to say, everybody.
When a work is done and there is change
Whatever
in
the
position.
total work, remember, Mari, the total work done
Total
to set into the body into what? To set into the body into
motion.
motion from where?
Motion.
From where?
Maybe.
From
Yes, sir.
rest, which is equals to energy, the total kinetic energy stored in the body. That is what you have to remember. Clear, everyone? All of you? Yes, please.
Sir.
Yeah. Niroshi, did you understand everything?
Yes.
So this is
Yes,
what
sir.
kinetic energy we say. Now let us understand what is the derivation for kinetic energy. This is the most important concept. So very important. So please all of you keep reading. Derivation of expression for kinetic energy. Derivation of expression for kinetic energy. Derivation of expression for what? Kinetic energy. So for that purpose, write it. Consider a body of mass m. Consider a body of what? Consider a body of mass m. Yes, Kishore, hammer hitting the nail is a kinetic energy. the total work done by you to make the hammer to move, which is equals to energy possessed by the body. And you see that moving hammer only, Kishore is a good example he has given. Hammer, moving hammer will makes the nail penetrate into the wall, or the stationary hammer will makes the nail penetrate into the wall. Which one? Anybody? Which one will makes the nail penetrate into the wall? Moving hammer or the hammer which is in state of rest? Anybody?
Moving hammer.
Moving hammer.
Moving hammer. Why? The whatever the energy possessed by you, the work done by the hammer, which is equals to total work done by the hammer, which is equals to energy possessed by the hammer. That moving hammer only makes the another body into motion. Am I right or wrong? Everybody? Clear? So then only the nail will penetrate into the wall. Am I right or wrong, guys? Everybody?
Yes, sir.
Yes, please.
Yes, sir.
If you imagine there is a hammer, okay? So now hammer is in state of rest. So what you will do? You want to lift it. So, and you have to apply a force to lift. You apply the force and this hammer is traveling a distance. And here is the nail to the wall. Here is the nail which is actually waiting to go into the wall. So what will happen? The total force applied by you on the hammer makes the hammer to displace. So which is equals to what? Work done, total work done on the hammer. Am I right?
Yeah.
Total work
Yes,
done
sir.
on the hammer, which is equals to what? Energy possessed by the body. What energy it is?
Kinetic energy.
Kinetic energy.
This kinetic energy only makes the another body. Actually, nail is in what now? State of what? Rest. Yes or no? Nail is in state of what? State of rest. So this kinetic energy, the moving hammer only makes the nail go into the wall. Means the nail is started moving because of the moving hammer. Am I right or wrong? Everybody? Yes, please. All of you.
Yes, sir.
Respond. That is what you have to remember it. Okay. So this is what about what is kinetic energy. So now we are going to study what? Derivation of expression for what energy? Everybody. Please
Kinetic
respond. Kinetic
Kinetic
energy. Okay. So for that, I told you to make assumptions like consider a body of mass m. All of you. Consider a body of mass m. Consider, write it. Derivation of expression for kinetic energy. Derivation of expression for which energy, everybody? For
Kinetic.
kinetic energy. So for that, what is the things? Consider a body of mass m. Consider a body of mass m. Let consider a body of mass m which is at rest. Which is at rest. Which is at rest means what is the initial velocity? Pakranga.
0.
Zero.
Let a constant force F act on it. Let a constant force act on it. Write it. Let a constant force act on it. Constant force F. Constant force, right next F, capital F, act on it and displace it through a distance. Displaces through a distance. From where to where? Check it, everybody. Displaces through a distance. What is the distance? Displaces through a distance. How much? Yes.
Yes.
Displaces through a distance. Yes. In time t. How much time? In time t. Do you all understand, everybody? Yes, please.
Yes, sir.
Yeah. Now applied force is what? Constant. Do you understanding? A constant force continuously applying. Constant force is continuously applying. So if the constant force is applying continuously as the body is in state of rest. So what is the initial velocity? Everybody? Zero.
Zero.
And after certain time, what is the velocity, Agalya? Velocity acquired by the body.
Yes, sir.
After certain time. Yes, please.
V.
Yes.
V.
Let V be the
But
yes. velocity of the body, let V be the velocity of the body at the end of time t. At the end of what? Everybody? Time t. Okay. Now, so initial velocity evalama? Initial velocity 0, final
Zero.
velocity v. Now we all knows that acceleration produced in the body. How much anybody can tell me? The
P minus U by T.
yes.
V.
The acceleration formula, tell me. The acceleration produced. What is the formula for
Change in time.
change in time?
Change in velocity by time taken.
Produced in the body. Produced in the body. A is equals to what is the formula? Fastly. Change
Change
in
in
velocity.
velocity by time taken.
Change in
Velocity
velocity
divided
divided by time interval.
time.
Am I right? Shivani understand now? Kavya, Sangamitrai, that is what. So now we all knows that. So what is the acceleration equals to? Change in velocity means final velocity minus initial velocity by time. So final velocity is v. Initial velocity is what?
Sir, initial velocity minus final velocity.
Ah, who is that girl? Agalyana. Acceleration formula what?
Sir, initial velocity minus
Minus U
final
by
velocity.
T.
What Agalya? Everything you forgot.
Sorry, sir. Sorry, sir. Sorry.
What is the formula, Ra?
P minus U by T.
Final velocity minus.
That is what. So what is the acceleration, everybody? Acceleration finally what? V by T. Am I right or wrong? Yes, please. Let me take equation number 1. Till here, any doubt, anybody can ask me. Is it okay, guys?
No, sir.
All of you understand?
Yes, sir.
Yeah.
Yes, sir.
Yeah. Any
Yes,
doubt?
sir.
Please let me know. Clear, everyone? Now, force acting on the body. How much it is? Tell me. Force acting on the body.
If
We all know the formula. Formula, tell me. Force acting on the body.
mass into
Mass into
acceleration.
acceleration.
We have considered let mass is m. Am I right, everybody? We don't know
Yes,
how
sir.
much mass. Clear? Force acting on the body is given by how much they have given? F is equals to
Mass
mass
into
into
acceleration.
acceleration. So now mass is m, acceleration. Substitute the equation 1 in this. What will happen? Okay, let this me take equation 2. Substitute equation 2 in equation 1 in which equation? Equation 2. So now acceleration means how much we got acceleration? V by T. Am I right or wrong? Please respond, everyone. Clear?
Yes, sir.
Yes. So this is what it is. All of you. So let me take this is equation number 3. What is this, everybody? Equation number? Yes. Equation number 3. Now, all of you observe very carefully. Use your, if the body is constant force is applied, acceleration, uniform acceleration, then can you tell me what is the average velocity? If the body is moving with a uniform acceleration, what is the average velocity formula? The displacement of the body is given by, if you notice it, it is S. So it is applied force is constant, means acceleration is also remains constant or not? Uniform acceleration. Am I right or wrong?
Yes, sir.
Yes, please. All of you,
Yes, sir.
please respond. F is constant.
Sir.
So can you tell me the displacement given by the body? How to find it? As it is displacement of the body. As the body is said to be in constant force. Displacement of the body. Can you tell me what is the formula? S is equals to.
T
Please.
plus half AT square.
UT plus
No.
half it.
Don't go with that, Mari. Displacement of the body. The body is applied constant force. Constant force means uniform acceleration. So if the body is in uniform acceleration, can you tell me what is the average velocity formula? V average is equals to
V plus U by 2.
total displacement. V average is equals to what is the formula? Yes, please.
Total displacement by time.
Total displacement by time. So now from that, displacement is equals to what? Constant force is applying. The body is continuously is motion. So what is the displacement is equals to? Everybody. Displacement is equals to
0.
V average into time. Am I right or wrong? Yes, mister? Yeah. If the body is in uniform acceleration, can you tell me what is the V average formula? If the body is in uniform acceleration, V average formula. Just now said Nivedan. Initial velocity plus
V minus
final velocity divided
final
by
velocity
2.
divided by 2.
That's all.
2.
So the displacement of the body is equals to, what is the formula? Average velocity into time. Average velocity into everybody time. So we all knows that the constant force is applied. Constant force means uniform acceleration. So then what is the average velocity formula? Everybody. Initial velocity plus final velocity divided by 2 into time is how much?
Time.
Time. So we all knows that initial velocity is equals to what? Initial velocity is equals to what? Response. Zero. So means, can you tell me what is the displacement is equals to? V by 2 into
V
By 2 into
is
time.
equals to, can I
2.
say VT by 2? Am I right?
Yes, sir.
Let me take, this is equation number 4. Anybody having any problem? Yes, please. All of you.
No, sir.
Yeah, no. Now we have studied one statement about the kinetic energy. Anybody can read your textbook, your notebook, what you have written, kinetic energy? The work done on the body is stored in the form of what? Read the statement. The work
Right.
done in the work done on the body is
Is
stored
stored in the
in the
form of
form of
kinetic energy.
kinetic energy. Okay, so here I will solve. So please continue. The work done on the energy, the work done on the body, which is equals to the energy stored, kinetic energy stored in the body. Am I right or wrong, guys? Everybody, please respond. All of you.
Sir.
So work
Yes.
done by the force, work done by the force is given by, what is the formula? Work done by the force. Anybody? Work done formula.
Yes, yes.
Force into displacement.
Displacement.
What is the force we got it? Force we got it. mv by t into displacement vt by 2. Am I right? Yes, please.
Yes.
That's all.
Yes, sir.
Yeah. So here not into, you
Cancel.
should put what? Yes, you should put dot. Now something will cancel. Anybody?
TT.
Yes, please. TT will get
T.
cancelled. And this 2 I will bring front. 1 by 2 I will write it. Anything wrong? Into m into v is what? V square. So the total work done on the body is how much? Total work done on the body is how much? Yes, please. Half mv square. Or you can say mv square by 2. What we can say? mv square by 2. Now here you should write it. The kinetic energy can be expressed as the amount of work done by the body before coming to rest. Am I right or wrong? Yes or no? So work done
Yes,
is equals to